All right, today we're cracking open what I think is the ultimate toolkit for any support engineer. For solving those super tricky, I can't reproduce it kind of bugs. We are going deep into the Chrome DevTools Network tab.
I mean, we've all been there, right? You get that ticket. The user says the page is just dead. The console doesn't show any errors. Everything looks perfectly fine, but the app is totally unresponsive. It is one of the most frustrating tickets you can possibly get.
But here's the good news. This isn't some unsolvable mystery. The clues are all there. They're just hidden in the network traffic. We just need to know how to find them. And our magnifying glass for this whole investigation is the network tab. So let's get into it.
Okay, so first things first. In any investigation, you gotta understand the scene of the crime. When you pop open that network tab and hit reload, you get this log. Now I know it looks like a lot, but it's actually incredibly organized. Every column here is a piece of the puzzle. The name is just, what file was requested. Status, this is a big one, tells you if the server said, yep, here you go, with a 200, or nope, can't find it with a 404. Type lets you know if it's a script, an image, or, crucially, a data request. And the waterfall? That gives you this really cool visual timeline. Seriously, think of this table as your mission control dashboard. This is where you're going to spot your first clues. So a typical web page can have hundreds of these requests firing off. Trying to find one bad apple in that giant crowd? Yeah, that's pretty much impossible. So the first thing any good detective does is narrow the field. We've got to filter out all the noise. For our dead page problem, the bad guy is almost always a failed data request. The page structure loaded just fine, but the data that makes it all interactive, it never arrived. So by clicking that fetch/XHR filter, we instantly just hide all the images, all the scripts, and we get to focus only on the API calls. But sometimes, even that's not enough. If you have a hunch and you know the name of the API endpoint you're looking for, let's say it has API/user in the path, you can type that right into the filter box. And just like that, you've isolated the one specific request you need to interrogate. All right, so we've used our filters. We've isolated a prime suspect. It's standing out from the crowd, probably glowing red. Now it's time to bring it in for some questioning and really dig into the details.
Yeah, see? Failed requests are almost always highlighted in red. It's your big visual cue. A status code in the 400s means it's a client error, like a bad request, or maybe you're missing permissions. A 500s error? That points the finger right at a problem on the server. So let's click on this red entry and open up a new panel with all the evidence we need.
The Headers tab, think of this as the official transcript of the conversation between the browser and the server. It shows you the exact URL, the method like get or post, and all the nitty-gritty headers the browser sent along. And it also shows the response headers from the server, which can have really important clues inside. And now for the confession. The Response tab shows you the raw, unfiltered data the server sent back. If there's an error, this is where you're going to find the server side of the story, usually a really specific error message like invalid user ID or permission denied that tells you exactly what went wrong. But what if the request didn't fail? It was just incredibly slow. Well, the Timing tab tells you why. It breaks down the entire journey of the request. The one to look for is the waiting TTFB bar. That stands for time to first byte. If that bar is really long, it means the browser sent the request and then just sat there, waiting and waiting for the server to even start talking back. That's a classic sign of a slow server or a bogged-down database. So, we found it, the smoking gun. We know which request failed and we know why. But our job is not done yet. We need to package this evidence up so perfectly that a developer can reproduce the issue in like 2 seconds. And this, right here, is the single most powerful feature for any support engineer. Just right-click the failed request, go to Copy, and then select Copy as curl. What this does is it copies a command line instruction to your clipboard that perfectly, 100% replicates the browser's request. This thing isn't just a log file. It's an executable replay. A developer can paste this command straight into their terminal, hit enter, and see the exact same error you did. This completely eliminates those, well, it works on my machine conversations. You're giving them cold, hard, undeniable proof. It's a game changer. So let's just recap our entire investigation. We took this really vague report of a dead page and we turned it into a concrete, actionable bug report. Let's put it all together into a workflow you can literally use every single day. This 5-step process is your new playbook. Step 1, reproduce the bug. 2, filter for API calls. 3, look for the red flags. 4, inspect the details. And 5, use copy as curl for the perfect handoff. I promise, if you follow these steps, you'll be faster, way more accurate, and your development team will absolutely love you for it.
And case closed. But now that you have these skills, just think about it for a second. What other mysterious issues could you solve with this? Missing images, forms that refuse to submit, data that just won't save? The network log holds all the answers. You just have to know how to look.